to JMath.
So let's look a bit at grade 11's quadratic number patterns. So we're just going to do a quick overview. If you need more in-depth explanations, please go to the grade 11 playlist where we taught you this for the first time. That would be much more in-depth. We're just going to fly over now. So we're all going to start with the Tn formula, an squared plus bn plus c. Now, for some of you who are very awake, you will notice that that is the same formula as a trinomial standard form, which is the same formula as a parabola's standard form. Now, remember, all of these concepts are linked. And in the most difficult exam questions, they are going to ask you parabola questions, but they're going to give you a pattern. So we'll get back there at the end of this playlist when we look at advanced exam questions. But for now, let's just remind you of the basics. So when you get a quadratic pattern, you must please remember these three bottom equations. So we always start at the bottom. Now remember, a quadratic number pattern has a first difference. If I take the second term minus the first term, I am going to get a first difference. And then if I minus the first terms, also right minus left, I'm going to get a constant second difference. And that's where these formulas come in. I'll do an example now, but please memorize this. It is not on any formula sheet that you'll ever get in an exam, so you must remember this. I can't tell you how many times people have lost marks because they make this a minus, or they switch the 2 and the 3, or something weird like that. And then they actually studied, but because of stress, they mixed up a few things. The only way to overcome that is to practice so much that this is second nature to you. Okay, let's start. If I read that top sentence, in grade 12, you'll always get one or two or three grade 11 number pattern questions. Okay, but this is not going to be the simple ones where it's just get the formula. There's normally some kind of trick to it where you need to get the maximum term or prove that it's always positive or something like that. But let's go through the basics so that we can build up to that point. Okay, the first example. Consider the quadratic number pattern 3, 11, 21, 33. Determine the Tn formula, calculate the 12th term, and which term is equal to 497. All of these are questions that you can really expect in your tests. Okay, question A. First thing I'm going to do is I am going to get the difference between the terms. So I'm going to say 11 minus 3 gives me 8, 21 minus 11 gives me 10, 33 minus 21 gives me 12. Then I'm going to do it again. So remember, I'm always doing right minus left. So 10 minus 8 gives me 2, and 12 minus 10 gives me 2. Because that bottom row is constant, that means it's a quadratic number pattern. Sometimes they ask you, prove, why is this a quadratic number pattern? Then you just need to show that there's a constant second difference. Now, I am then going to use the formulas that we just saw in that other sign I showed you, and I'm going to say 2a must be equal to the bottom number, 3a plus b must be equal to the middle number, and then a plus b plus c must be equal to the top number. Okay, those are the equations I did here to the right. So 2a is equal to 2, that means a is 1. Now I'm going to take this 1 and I'm going to sub it in there. 3a plus b is equal to 8. That means that b is 5. And now I'm subbing in the a and I'm subbing in the b, and that's where I get the value of c equals minus 3. Now I put them all together to get my Tn formula. Okay, now if I need to tell them what is the value of the 12th term, remember, if they give me a position, I always sub it in the place of n. If they give me a value, I make the equation equal to that value and solve for n. Please don't forget that, guys. Okay, let me zoom out so you can see the full picture. And question B. What is the value of the 12th term? I'm just subbing it into the place of n each time, typing it in my calculator, and that tells me that this answer would be 201. For question C, they gave me a value and they asked me for a position, so I'm just going to make the 497, I'm going to sub in the place of Tn, as you can see there. I'm moving it over, that gives me a trinomial. I solve the trinomial in any way that you are comfortable, whether you use the quadratic formula, you use your brain, or you use the white calculator to solve it. Anything goes as long as you get two answers for n. Now, very important. Remember, in this whole chapter, n can never be negative and n can never be a fraction. That's why I'm cancelling the minus 25, because if I ask you, what is the position of this term? You can't tell me it's the minus 25th term. We don't count backwards when we say patterns. We always count forwards, and we don't count in halves or quarters or whatever. Always just whole numbers, integers. Okay, that is a basic example. Now, if we look at a bit more advanced, is when they bring in algebra. And this is now where this note is very important. Always do right minus left. And because it's quadratic, we do it again. And then the goal is to set up a few equations and then do algebra to solve this question. So find the value of x and y, and then they give me a quadratic pattern. And the only info I have is that this is quadratic. And that's why I'm going to say right minus left. So that gives me this value. And then I do that again and again and again. Okay, that gives me the row of first differences. Now, if I go again and I do right minus left, I'm going to get the constant second difference. And the important word there is constant, which means I can put an equal between them and then do two at a time and solve for x, and then do the right two at a time. And that's going to solve me y. Guys, you can look there. I'm not going to go step by step. You have it in front of you. But now let's go into detail and do this together so that you can follow me. Right, determine the general term for each of these quadratic number patterns. So the first thing I'm going to do is I'm going to rewrite this, but with enough space, and please leave a gap on the left. So I'm going to say -2, leave a space, -9, -22, -41. I'm then going to say right minus left. So -9 minus -2 gives me -7. This gives me -13. This gives me -19. Then I'm going to go again. -13 minus -7 gives me -6. And then this also gives me -6. And there's my constant second difference. Now I'm going to use the formulas. I know 2a must be equal to the bottom number. 3a plus b must be equal to the middle one. And then a plus b plus c must be equal to the top one. Now, please always do this on the left. This does not work if you do it on the right. So don't even try it. We're starting at the bottom and we're going to solve. So we said 2a is equal to -6. That means a is equal to -3. I'm now going to use the -3 to sub it in the middle formula, and that's how I'm going to get b. So I'm just going to make a bullet so you can follow me where I am. And then I'm going to say 3 times -3 plus b equals -7. That gives me a -9. And if I say b is equal to -7 minus -9, that would become +2. Okay, now to solve the last one, c, I am going to use my a value and my b value and sub it into the top equation. So I'm going to say -3 plus 2 plus c equals -2. If I take everything over, it looks like c is going to be -2 minus 2 plus 3, and that says c is equal to 1. And now I can just rewrite the formula as Tn is equal to -3n squared plus 2n plus 1. And there we go. That is the general term of this quadratic pattern. Question 2, so now it looks horrible because there's fractions, but it really is not that bad. So if I say -4.5 minus -1, that gives me -3.5. The next one, -10 minus this gives me -5.5. Guys, you are welcome to use your calculator for this. Just get the answer correct. And now if I take again right minus left, I can see this is just -2, and this is also just -2. I can now set up my formulas. Remember, 2a is equal to the bottom number, -2, and so I'm going to solve it immediately. So a is equal to -1. Now I'm going to take the middle formula, 3a plus b, so 3 times -1 plus b must be equal to -3.5. Take that over, and then b is equal to -3.5 plus 3. That just gives me -0.5. So now to get c, -1 minus -0.5 plus c must equal -1. And therefore, -1 plus 1.5 just gives me +0.5. Wonderful. Now I can just rewrite the Tn formula, and that would be Tn equals -1n squared minus -0.5n, and then plus 0.5. Now we get to one of those questions with a bit of algebra in it. But we're just going to follow the same steps. So because this is quadratic, I'm going to say right minus left. So let me just write it down and give myself enough space. And this time they're not asking me to get the general term. They're just asking me to solve for x. So I don't need to leave a space on the left. You can if you want to, but it's not necessary. So right minus left, 8 minus 2 gives me 6. And now this is x minus 8. This one is 26 minus x. Okay, so my spacing is a bit off because these terms are a bit bigger. So when you write it down, give yourself enough space from the start. Now I'm going to right minus left again, but focus with this one. Right would be x minus 8, and then minus 6. The next one would be 26 minus x, and please, please, please use a bracket. Okay, otherwise your signs are going to be wrong and you are not going to solve for x. Now, because this is a quadratic pattern, I can put an equal there. And that's where I can now start using algebra and solve for x. On the left, I can see that this would just be x minus 14 equals, and if I go with this, 26 minus x plus 8. And I want all the x's on the left. So I can see x plus x would give me 3x on the left. And then on the right, this would be 26 plus 8, which is 34. And 34 plus 14 gives me 48. Divide by 3, and x would just be 16. Okay, now they don't ask you this, but I would always, if it's my exam, I want to be sure before I move on to the next question. I will sub this in and just see, do I get a constant second difference if x is 16? Then that would show me immediately if I made a mistake or not. So I know this is 6, this is 8, this is 10, and there we go. The constant second difference is 2. I know I'm 100% correct with this question. The last question we're going to look at is a bit of a word sum. So just read very carefully. So write it out as a number pattern. Give yourself enough space. Whenever there's a gap, put an X. And if there's another gap, put a Y. Okay, let's read. A certain number pattern has a constant second difference of 4. The first two terms are equal, and the sum of the first three terms is 16. Determine the general term for this sequence. Sounds very complicated, and it sounds like they're not giving you enough info, but they actually are. So I know there's a number pattern, term 1, term 2, term 3. And I know there's going to be a value, there's going to be a value, and then the constant second difference is 4. And that's all I know. Other part they tell me, T1 plus T2 plus T3 is equal to 16. Okay, now that does not give me a lot. But let's now fill in x's, and then you'll see it's actually not that bad. So they're telling me the first two terms are equal. I'm going to replace this with an x, and I'm going to replace this with an x. And now in my second equation, I can now also replace these with x's, because I know they are equal. I don't know what they are, but I know they are equal. And that now helps me to get a value for term 3 as well, because I can say term 3 is equal to 16 minus 2x. Now I'm going to replace that, and then I can actually solve this question. So this one would be 16 minus 2x. Now, once again, I think I didn't give myself enough space, but let's see. To get the middle row, I just need to say right minus left. So x minus x is 0. It doesn't matter what x actually is. If I minus it from itself, it's going to give me a 0. The next one, right minus left. So 16 minus 2x minus x. Now, I also know that to get the constant second difference, I need to say right minus left again. And this is the equation I'm going to use to solve the question. So I'm going to take the 16 minus 2x minus x, and I'm going to say minus the left one. So guys, remember I'm doing right minus left must equal to 4. Okay, and in this case, my right would be 16 minus 2x minus x, and my left would just be 0. Now, my equation says 16 minus 3x would equal to 4. I'm going to take the 3x to the other side and say, okay, but this would then be a 12 is equal to 3x, and therefore x is equal to 4. Now, once again, in my exam, I would want to know if I'm right, if I can move on to the next question. So I'm going to fill this in. I know the first two terms must be equal, and that would just be 4 as I worked out. And then the next one would be 16 minus 2 times 4. That gives me 16 minus 8, which is just 8. So then I know this would be 0, and then 8 minus 4 would just be 4, and that gives me a constant difference of 4. Great. I know I'm correct with that sum. I can move on. So that was a quick revision of quadratic number patterns. At the end of this playlist, we are going to look at the last 3 years, which questions on quadratic patterns were in exams, and we're going to do them together. So please make sure you know this so we can advance to the more difficult things.
If this video helped you, please like and subscribe.
JMath.